guys, welcome to Space Talks, and today we're going to be talking about the Mars 2020 rover known as Perseverance and the Ingenuity Mars helicopter. So before we get started, I'd like to give a brief explanation of what are their main purposes. So Perseverance will seek signs of ancient life and collect rock and soil samples on Mars for possible return to Earth. And Ingenuity is a technology demonstration to test power controlled flight on another world for the first time. It hitched a ride to Mars on the Perseverance rover. So it was launched in July 2020. 30th July to be exact, and it was launched in an Atlas V541 launch vehicle, as you can see here. And from then, it took 7 months to arrive to Mars. So it arrived on Feb 2021. And on Mars, its landing site was Jezero Crater, as you can see here. Now, Mars 2020 rover actually weighed more than Curiosity. So it weighed 1,025 kg to 1,050 kgs, approximately. So they will still use the sky crane system, like they did with Curiosity, to land Perseverance. So this is how the sky crane system looks like. In the landing system, there are two improvements. These are range trigger first. So range trigger is basically once it's in the right place, it will allow the parachute to deploy at the right time, like this. And then we have turn relative navigation, that's TRN. And that's a series of images that will be loaded into the software of the rover, and as it's looking down at the ground, it will compare what it sees with its radar to the images that are loaded on board, so it will be able to divert from any obstacles it sees. And once on the ground, it will have one Mars year to complete its prime mission, and it can go 20 kilometers across the surface. All the hardware on the rover is going to last for about 1.5 Mars years to give a little cushion in terms of warranty. And this rover is actually a little similar to Curiosity. And well, this is what it looks like. Over here, this is Perseverance, and this is Curiosity. And to save money, we kind of used a little of Curiosity's design instead of coming up with a new one, because it would take more money. And of course, it has an entirely new instrument package, only that some instruments are similar to Curiosity. And it's powered by nuclear power, not solar panels. And we will talk more about instruments in the coming slides. So now, these are the types of instruments on the 2020 Mars rover. So there's loads here. That's matter electronics and pressure sensor, impact electronics, supercam calibration target, etc. And as you can see, some are contributed by different countries. As you can see, their flags. Now first we're going to talk about some of Perseverance cameras and some of its main instruments. So here is Mastcam Z, the camera, and it's located on the yellow parts here. So now I'd like to show a little representation of the kind of picture Mastcam Z would take comparatively to Curiosity's picture. And I'm sure it will help you understand how powerful this camera is in terms of photography. So as you can see, this pic was taken by Curiosity with great detail that these cameras provide, because you can see great geological formations like hills and lots of rocks around. And that helps a lot. because you can see the layering or difference between rocks too. Now imagine if this image was zoomed in 3 times. Yeah, so the Mastcam-Z will give us a lot more detailed information comparatively. And now we're going to talk about SuperCam, which is located here and here on the yellow parts. So SuperCam is CamCam and a few other things. Now CamCam means it looks at rocks and soils from a distance, and then it fires a laser and analyzes the elemental composition of rocks and soils. Another thing that makes it SuperCam, except for CamCam, is that it will have a visible and near infrared spectrometer to do mineralogy of rocks from really far away too. And here is a picture of before and after the laser was fired into the rocks. So here's before and after. So here there's tiny holes, if you can see, and that's where the laser was fired. And one thing it can do once it makes holes is it can actually look inside those really, really tiny holes. And it will get a really clear view and get an idea of the nature of the sample by just looking at the material left behind. Next we have Sherlock, So we have Sherlock and Watson. So these are where they're located, and now first we're going to talk about Watson. So it was used a little on Curiosity to take some lovely selfies of itself as it's on the surface of Mars. So in this, they take a bunch of pictures with the instrument called Molly on Curiosity, and they stitch them all together to make these selfies. And the Mars 2020 rover will also be taking some selfies like Curiosity. And now Watson is a companion of Sherlock in this case, and it's a microscopic imager. So it's sort of like a hand lens so that we can look things relatively up close. And it has a full form actually, that is wide angle topographic sensor for operations and engineering. To put it simply, its real purpose is to really study the material up close and fine detail, like this picture here. And to get all the composition and size, etc., it has to check all its properties. And that's what Watson does, really. Next, we come to Sherlock. And now Sherlock has a full form like Watson, that is scanning habitable environments with Raman and luminescence for organics and chemicals. So mostly the name itself gives away its meaning. And here's a picture of Sherlock. So it scans for habitable environments on Mars using an instrument called Raman spectrometer, and it can analyze luminescence. And it's great when looking for organic compounds. And lastly, we'll be able to look for organic material, and we'll be able to look for particular kinds of minerals in these rocks, and that indicate different things, like chemicals. So as you can see, here's where it's scanning, and here's what it found out. So this is a little image of scanning with luminescence and some microbes here. And now we have Pixel, that's over here. And that stands for Planetary Instrument for X-ray Lithochemistry, which means it identifies chemical elements at a really tiny scale. Pixel also has a camera that takes super close-up pictures of rock and soil textures. It can see features as small as a grain of salt. Together, this information helps scientists look for signs of past microbial life on Mars. And these were the primary instruments. And now I'll be giving a really brief explanation of the others. So then we have RIMFAX, and it can detect ice, water, or salty brines of more than 30 feet or 10 meters beneath the surface of Mars. And then we have MEDA, and it stands for Mars Environmental Dynamics Analyzer. It can measure temperature, humidity, wind, and it's also a dust analyzer. And finally, we have MOXIE, and here it is. And this is the Mars Oxygen in Situ Resource Utilization Experiment, and it's better known as MOXIE. MOXIE will demonstrate a way that future explorers might produce oxygen from the Martian atmosphere mainly for breathing, and it is quite important. So these are all the cameras and instruments we've been through. So we've been through SuperCam, that's the laser micro imager, Mastcam Z, the zoomable panoramic cameras, and then Pixel, the X-ray spectrometer, Sherlock and Watson, the ultraviolet spectrometer, and the camera, and then RIMFAX, the subsurface radar, MEDA, the weather station, and MOXIE, that produces oxygen from Martian CO2. That's basically carbon dioxide. And of course there are a lot more instruments, but these were mainly the main ones. And along with these, we also flew the helicopter on Mars called Ingenuity. And it would have lowered after the rover had landed, and as it lowers and unfolds, the rover will move away, and then the helicopter will take a few test flights. As it's the first time there has been aerial flight on Mars, because the atmosphere is very thin there. So it will be really challenging. And just a little extra part, there is the sampling and caching system, in which samples will be stored and left on Mars, so that in the near future, when humans visit Mars, we can pick up those samples and bring them back to Earth if everything goes to plan. So these are the parts of the sampling and caching system. So you might have heard that it will be left on Mars, and well, it will be, because well, the rover can't come back to Earth. So in the future, perhaps when humans visit Mars, we're gonna go and collect those sample tubes and bring them back to Earth. And then we have just a little timeline of the way it's going to land and when will we come to get it. So first from Earth, it cruises, and when it's about to land, it comes in the atmosphere and the parachute deploys. And so the rover will come down with the Skycrane system along with Ingenuity. And then we will retrieve the samples on Mars and we'll put them here. And then humans will come, they'll come down, take the samples, go to the rocket, launch back, and rendezvous at a shuttle. That shuttle will return to Earth. So thank you for watching, and to know more about this mission, visit mars.nasa.gov. If you have any doubts or you want me to do videos on any particular topic, you can write it in the comment section down below. So thank you.